Today we will mention about the relations between planes and lines. Okay. The first one, obtaining planes parallel to the coordinate axis by using lines. Actually, these long titles tells us that if you have this line, let's say x minus x sub 0 over p, y minus y sub 0 over q, and z minus z sub 0 over r. Okay? So then, when you consider two of them, let's say the first one is this. Consider this together, this and this one. So if you consider this one, we have this one, x minus x sub 0 over p, y minus y sub 0 over q. So here, if you make a cross product, then you have q times x minus q times x sub 0 equals p times y minus p times y sub 0. Or we have this one, q times x minus p times y minus q times x sub 0 plus p times y sub 0 equals 0. You see, you have this equation. So this part is number, this one, some real number. Because here everything is number, q, p, x sub 0, y sub 0, or all are numbers. So then we have this form, q times x minus p times y. So you see, this is actually in this form, a times x, right? b times y plus d equals 0. So this represents the plane parallel to the z-axis. So similarly, the other parts. So we considered only for first two terms. So consider the others. The other one is this, x minus x sub 0 over p, z minus z sub 0 over r. So if you write this one, you have r times x minus p times z minus r times x sub 0 plus p times z sub 0 equals 0. Also, so this is the plane parallel to which axis? Y-axis. Similarly, the other part, so what remains? Y minus y sub 0 over q, z minus z sub 0 over r. So here you have r times y minus q times z minus r times y sub 0 plus q times z sub 0 equals 0. So this plane parallel to x-axis. So if you have one line, then you can construct three planes which are parallel to the coordinate axis. Okay, consider now example. The first one. Given the line x minus 1 over 2, y plus 1 over negative 3, z minus 3 over negative 2. Find three planes parallel to the coordinate axis. So this is just application of the above information. First, let me write this one. X minus 1 over 2, y plus 1 over negative 3. This is negative 3. So you have this one, negative 3 times x, negative 2 times y, plus 3 minus 2 equals 0. So you have negative 3 times x, 2 times y, plus 1 equals 0. So similarly, you have this one, x minus 1 over 2, z minus 3 over negative 2. So you have negative 2 times x, negative 2 times z, plus 2, plus 6. So in this case you have negative 2 times x, negative 2 times z, plus 8. Or you can write x minus plus z minus 4 equals 0. This is another one. The last one. So remaining part, y plus 1 over negative 3, z minus 3 over negative 2. So this time you have negative 2 times y plus 3 times z, negative 2 times 1, so plus negative 9. So that's why you have negative 2 times y plus 3 times z minus 11 equals 0. So we have three coordinates, planes parallel to the coordinate plane axis. Okay, let me give one more example for this one. Find the equation of the plane parallel to the x-axis and the line is this one, x minus 1 over 2 y plus 1 over 4 z minus 1 over 3, and passing through the point 3, negative 1, 5. Okay, let me change this line, okay? So, yeah. Okay, let's do this way. So, this one. So, z equals 5, okay? I changed the line. So we are looking for the plane which is parallel both the x-axis and the line, given this line, and also it's passing from this point. Okay, first, because it is parallel to the x-axis, it means we have this one, right? B times y plus c times z plus d equals 0. This is our plane. And also it is given parallel to this line. Now think about, you have this plane. Okay? And your plane is parallel to this line. So it means your normal vector, the plane, will be perpendicular, right? So this is our line. This line. So because if the plane is given, we know that this n is this one. 0, B, C, right? So n will be so this one, 0, B, C, will be perpendicular to 2, 4, 0. So from this you have 4 times B equals 0. So B will be 0. Okay. Now our plane will be simply, which has simple form. So it will only have C times Z plus D. Okay. Now, so our equation will be C times Z plus D equals 0. So this is our plane. But we have another information here. It is passing from 3, negative 1, 5. So 3, negative 5, negative 1, 5. So it means you have 5 times C plus D equals 0. So if you write this one, C over D equals negative 1 over 5, right? So C times Z plus D will be 0, or you can write C over D Z plus 1 will be 0, and you have 1 over 5 z plus 1 equals 0. So z equals 5. Actually, our plane is parallel to the x or y coordinate plane, not only x-axis, okay? So this z equals 5 tells that this plane we are looking for is parallel to the x or y plane. Okay, now intersection of planes. First, we will consider two planes. So we have this one. So and then another plane. So these two planes intersecting each other. So we have this common line here. This common line. So we are trying to find this line, okay? So let's say this is a plane, this is another plane, and this is L. So how to find this L? This is our problem. So let's say, let A1 times X, B1 times Y, C1 times Z plus D1 and the other one A2 times X, B2 times Y, C2 times Z plus D2 0 B2 planes. So to find the intersection line of these planes, it will be enough to find the common solution of the blue equation. Actually, these together, right? Okay, this one. So we know how to solve this equation. It is a linear equation, right? Okay, let me give example. Find the intersection line of the planes. So which one? 2 times x plus y plus z plus 1 equals 0, and x plus 3 times y 2 times z plus 5 equals 0. Okay, we will give 3 solutions here again. So first one, like we said, we will look the common solution for these 2 equations. So these equations, let's say 2 times x plus y plus z equals negative 1, and the other one, x plus 3 times y 2 times z negative 1. So if you look at this one, you have 2 equations, 3 unknowns. So you have 1, 3 minus 2, you have 1 parameter. So let's say this is solution 1. So I put the z as a lambda. Then you have this one. Okay, this z now becomes lambda. So you have this one, negative 1, negative lambda, and x plus 3 times y equals negative 5, negative 2 times lambda. So now we have simple equations. So you can use, if you multiply this one by negative 2, then you have 2 times x, y equals negative 1 lambda, negative 2 times x, negative 6 times y, 10 plus 4 times lambda. So from this we have negative 5 times y equals 9 plus 3 times lambda. So y becomes this one, negative 9 over 5, negative 3 over 5 lambda. Okay, z is lambda, y is this one. Okay, now if I put this information in the second equation, so this one, x plus 3 times negative 9 over 5, negative 3 over 5 lambda equals negative 5, negative 2 times lambda. So you have this one, x equals negative 5, negative 2 times lambda plus 27 over 5 plus 9 over 5 lambda. So x becomes 2 over 5, the first one, this one, and lambda negative 1 over 5 lambda. So we have three components. So our line is actually, we find the line because this is the line. Okay. So x is this one. So x, okay, let me, so x equals 2 over 5, 1 over 5 lambda, y equals negative 9 over 5, 3 over 5 lambda, and z equals lambda. Or you can write in this form, x minus 2 over 5 over negative 1 over 5 equals y plus 9 over 5, negative 3 over 5, and z over 1 equals lambda. Okay, our solution to this one. So finding 2 points. Okay. So our equation is here. This is our equation. So first, if for x equals 0, if x equals 0, you have this one, y plus z equals negative 1, 3 times y plus 2 times z equals negative 5. So we need to solve this equation. To solve this equation, it is enough to multiply the first by negative 3. So you have this one, negative 3y, negative 3 times z equals 3, and 3 times y plus 2 times z equals negative 5. So from this you have z equals 2. If z equals 2, we can find y, because y plus 2 will be negative 1, so y becomes negative 3. So our first point is this, 0, negative 3, and 2. So for y equals 0. So in this case, you have 2 times x plus z equals negative 1, and x plus 2 times z negative 5. So in this case, you have this one, 2 times x plus z, negative 1, negative 2 times x, 4 times z, 10. So in this case, you have 3 times z equals 9, z equals negative 3. Now, if z equals negative 3, it means x minus 6 equals 5. So you have x equals 1. Our second point, this one, 1, 0, and negative 3. So now we are looking at this one. So the line passing through these points. So let me write this one. So this one, x minus 0 or 1 minus 0, 1. So y plus 3 or 3 and z minus 2 negative 5. So let me, okay, this one. This is the line we are looking for. Okay, you may say, are these two lines are same? So we find here this one. Okay. Now look at this one. You have D for this one, 1, 3, 5, negative 5, right? So this one you have negative 1 over 5, negative 3 over 5, and 1. So this also is same. Okay? Why? Because let's say this one D1, D2. Okay? So D1 will be negative 5 times D2. So D1 and D2 are parallel. So they are same vector. So these two lines are same line, okay? It's not different. Remember, maybe I repeatedly told you that we are looking at the vectors as equivalence classes, okay? So if they in the same classes, we consider only one vector, not two. So because these two vectors are parallel, it means they are the same vector. So the line, because line is determined by this direction vector, okay? So you can find another point passing through. Okay, this is solution 2. Another solution, solution 3. Okay, solution 3. Now, in this case, we consider this one. You have, let's say, two planes. Okay, so maybe I should. Okay, these two planes. So we are looking to this line. Okay. So now, because we have these normal, let's say this normal n1, also we have this normal, let's say this one. Okay, let me change this one. This is a other normal, so this normal belongs to this P1, and this normal and 2, right, let's say this is P2. So this is L. So the direction vector of the line will be in the direction of n1 cross product n2. Okay, so we can consider, so D will be n1 cross product n2. Also you can find one point, so that's all, because if we have the normal vector and the point, the line is passing through that, then we can find the line, the equation of the line. So first let me find this D. D will be this one. Okay, let me, okay, where is, okay. Again, consider these together. Okay, let me write this in the so these are our planes. So n1 will be this one, 2, 1, 1, and 2 will be this one, 1, 3, 2. So D will be n1, 2, 1, 1, and 1, 3, 2. So our direction vector will be 2 minus 3, negative 1, 4 minus 1, negative 3, and 6 minus 5, 6 minus 1, 5. Okay, this is our direction vector. We also have one point. We already defined that point. Let's say this one. Okay, this point. You see how I find this point. So this is our point. So now we can write the line. The line is this. The line passing from 0, negative 3, 2, and having direction vector negative 1, negative 3, and 5. So this is our equation. The first is one, x over negative 1, y plus 3 over negative 3, z minus 2 over 5. So this is the line. You can write the parametric form. So if you put here lambda or t, then you have x negative t, y 3 times t negative 3, and z 5 times t plus 2. Yeah, this one and this one is same. So you can use all these three methods, but it seems the last one is easy, right? Okay, this is our first plane. This is the other plane. So they can intersection line. Okay, let me okay this, so I can of course change this. So these are, they intersect each other. So how about the line? Okay, let me tell the line. Yeah, actually we can see the line is this one, right? So let me write the equation. Okay, this is the line. Okay, you see our planes, and the red one is line. Of course, I didn't. I put some restriction for the boundary, but there is no boundary in general. Okay, another example. Okay, find the equation of the intersection line of the planes five times x plus y minus 3 times z plus 2 equals 0. Okay, negative 2. And x plus 2 times y plus 3 times z minus 1 equals 0. Also, find the plane find the plane passing through origin and containing the above intersection line. Okay, we have two questions here. So when you find the first solution, you need to use this solution in the second question. So first, let me find this one. 5 times x plus y minus 3 times z equals 0. And this one, okay, let me write in this form. And x plus 3 times 2 plus 2 times z equals 1. So because I need in the second problem, I needed 2 points. So that's why I will choose this one. So I will find the 2 points. The first one, so if x is 0, you have y minus 3 times z equals 2, 2 times y plus 3 times z equals 1. So from this, you have 3 times y equals 3, y becomes 1, and if y is 1, then you have 1 minus 3 times z equals 2. So from this, you have z negative 1 over 3. So our first point is this, 0, 1, and negative 1 over 3. This is the first point. The second point, I will choose the y as a 0. So in this case, you have this one, 5 times x minus 3 times z equals 2, and x plus 3 times z equals 1. Again, you have 6 times x equals 3, so x becomes 1 half. If x is 1 half, then 1 half plus 3 times z equals 1. So z becomes, okay, now the intersection line. So, okay, x over 1 over 2, y minus 1, negative 1, and y plus 1 over 3 over 1 over 6 minus 1 plus 1 over 3. So our line x over 1 over 2, y minus 1 over negative 1, and z plus 1 over 3. So this one will be z over 1 over 2. Okay, this is the intersection line. Now we are asking to find the plane. So this plane is passing from origin and containing this intersection line. If this contains this line, it means it contains the points on this line, right? So these three points will be on the display. So we are looking this one. So now the question, is to find the plane passing through 3 points. Zero, 0, 0. Let's say this is P1, and P2 is this one. We find that 0, 1, negative 1 over 3, and P3 is 1 half, 0, 1 over 6. So we know how to find this one. So if we choose the P, X, Y, Z, arbitrary point, then we need to find this one. So P1x, so this will be x, y, z. So the other one, 0, 1, negative 1 over 3, and 1 over 2, 0, 1 over 6. So we need to find this one. So first we have this one, 1 times. So I am here. 1 over 6 times x minus 1 over 2 times z. So now 2, 1, 2, 2, 2, 3. So we have 1 over 3. So now I am here. Negative 1 over 2y will be 0. So we have this one, 1 over 2 times x, 1 over 6 times x, 1 over 6 times x, minus 1 over 6 times y, 1 over 2 times z equals 0. Or you can write this one, x minus y minus 3 times z equals 0. Okay, now we will give another relation between plane and line. Okay, this one, the position of a line and plane relative to each other. Okay, now consider plane. Let a times x, b times y, plus c times z plus d equals 0 be a plane. And L, let's say L is this form, x minus x sub 0 over p, y minus y sub 0 over q, and z minus z sub 0 over r. A line. Okay, now we have, let's say this is a plane. What can we consider? So this is our plane. Now, the first case, it can be this one. So line is parallel to the plane. So how can we this L, this is P, plane. So, okay, you see, you have normal vector, and this normal vector, let's say, and also you have the direction vector for this one, for the line, okay? So you have direction vector. Now you see, if the line and the plane is given, then in this case, if L is parallel to the plane, so in this case we have this one, N and the direction vector orthogonal to each other. This is the first case. Second case. So again, you have this one, this plane. But in this case, okay, again, you have this one. This is the plane. This is the line. So in this case also, your this N and D, so N is and D again perpendicular to each other, but L lies on the plane. So be careful if the N and D is orthogonal to each other, it doesn't mean always it is parallel to the plane. So it may lie on the plane, okay? This is the case. So another case, so this one, so in this case, let's say this is the line, okay, but it's passing from this one. So this L, this P. So the line L and P intersect each other. Now, if L is perpendicular to P, L is perpendicular to P, if and only if this D and N will be parallel. Okay? So what I mean, this one. So you have this one again. Oh, okay, the line intersect the plane, but intersect perpendicularly. So this one. So in this case, this is L. Also, you have this one, right? Okay, let me write the other parts here. So this is N. So direction and N will be same. Okay. So this is the case we can consider. but you don't need to memorize these cases, okay? So with this will happen when you calculate. So how to calculate? If they have a common point, so it means if they intersect each other, we can solve together, and if we find the solution, it means they have an intersection point. Otherwise, they don't. So we consider these together. A times x, b times y, c times z plus d equals 0, and x minus 1 or x minus x sub 0 over p, y minus y sub 0 over q, and z minus z sub 0 over r equals, let's say, lambda. So it means we have this one, x will be lambda times p plus x sub 0, y will be q times lambda times q plus y sub 0, and z equals lambda times r plus z sub 0. Okay, now we put this in the plane equation. So you have this one, lambda times p x sub 0 plus b times lambda times q plus y sub 0, and c times lambda times r plus z sub 0 plus d equals 0. Okay, now I am trying to find the lambda. So that's why I put in this form lambda times a times p plus b times q plus c times r plus a times x sub 0, b times y sub 0, c times z sub 0 equals 0. So then you find the lambda. Lambda becomes a times x sub 0 plus b times y sub 0 plus c times z sub 0 over a times p, b times q, c times r. This is negative. Now, if we find the lambda, so if the lambda exists, then we can say that, okay, there is a common point here. So when you put this lambda in this equation, in the line equation, you find the x, y, and z. This is the intersection point. Okay? Other cases. So by looking at this lambda, we can say all the information we just mentioned above. So let me say, okay, the first case, if a times, okay, first let me consider this one. This one is n direction right, okay? So we can consider here the first one. If a times p, b times q, c times r equals 0, and a times x sub 0, b times y sub 0, c times z sub 0 is not 0, then the line is parallel to plane. because the normal vector of the plane and the direction vector of the line is perpendicular to each other, but the point x sub 0, y sub 0, z sub 0 does not satisfy the equation of the plane. These two equations tells this information. The second, if A times P, B times Q, C times R 0, and x sub 0 plus B times y sub 0, C times Z sub 0 equals 0, then the line lies on the plane. Okay? Because in this case, okay, N is perpendicular to D, they are orthogonal to each other. Also, this point x sub 0, y sub 0, z sub 0 satisfy the equation of the plane. So that's why the line lies on the plane. And third one, if A times P, B times Q, plus C times R is not 0, the line intersect the plane. Moreover, if A over P equals B over Q equals C over R, so it means if they are parallel, so then the line is perpendicular to the plane. Okay, now let's give the example. Check the position of the line. Line is this one, x over 2 equals y minus 2 over 3 and z minus 1 over 4, and the plane is this one, 3 times x plus y minus z plus 1 equals 0. Relative to each other. Okay, if the line intersects the plane, find the intersection point. Okay, now we will solve these two equations together. So first, x becomes 2 times lambda, y becomes 3 times lambda plus 2, and z becomes 4 times lambda plus 1. So then if you put this information here, 3 times 2 times lambda, 3 times lambda plus 2 minus 4 times lambda plus 1 equals 0. Okay, so 6 times lambda plus 3 times plus 2 minus 4 times lambda minus 1 plus 1 equals 0. So 6, 9, so 5 times lambda plus 2 equals 0. So lambda becomes negative 2 over 5. So this, because we find the lambda, it means the line intersects the plane. If we couldn't find the lambda, then we may check the n and d. Which kind of relations they have for the n and d. But now, because we find the lambda, there is no need to check that. So the intersection point is this. So x will be negative 4 over 5, and y will be negative 6 over 5 plus 2, so 4 over 5 is y, and z will be 4 times negative 2 over 5 plus 1, so 8 plus 5, so negative 3 over 5. So the intersection point is this, negative 4 over 5, 4 over 5, and negative 3 over 5. Times x plus y minus z plus 1 equals 0. This is a plane. And this is a line. Okay, this line. So from the graph we can see that this line and the plane, okay, they have an intersection point, but the line does not intersect the plane perpendicularly. So it is not perpendicular. I am saying this one, right? Okay. So you see, they intersect each other, but 2 over 3 does not equal 3 over 1, which is not equal 4 over negative 1. So they are not. So they are not orthogonal. There is no orthogonality. So this is our example. Check the relations between the plane 10 times x minus 20 times y plus 4 times z minus 70 equals 0, and the line x minus 5 over 2 y plus 1 over negative 3 z over negative 20 equals lambda. So check this one. So now I will give two solutions here. The first one, like we did before. So first find that this x becomes 2 times lambda plus 5, y becomes 3 times lambda minus 1, and z becomes negative 20 times lambda. So now put this information here. 10 times 2 times lambda plus 5 minus 20 times plus minus 1, and 4 times negative 20 times lambda 70 equals 0. So now check that these 20 times lambda plus 50, 60 times lambda plus 20, 80 times lambda minus 70 equals 0. So you see this side becomes 0 because 20 lambda plus 60 lambda becomes 80 lambda and cancel each other. So you have 0 this side and this side. 0 equals 0. So it means whatever lambda, it doesn't matter. For every lambda, this equation is satisfied. Because for the every lambda, this equation is satisfied, it means the plane contains the line. Okay? There is no lambda, but there is no any absolute case here. Okay, this is solution 1. Solution 2. Now again, D is this one, 2, negative 3, negative 20. Also the N is this, 10, negative 20, 4. So if you multiply these two vectors by inner product, so D N, so 20, 60, and negative 80, so it will be 0. So now we conclude this one. Either they are parallel or the line lies on the plane. Okay, to find this one, if the point in which the line passing from this point, if this point satisfies the equation of the plane, then it means they are parallel and the point satisfies this equation. It means the line lies on the display. So our point here, this one, P sub 0, 5, -1, and 0. If you put this one into the plane, 10 times 5, minus 20 times -1, plus 4 times 0, minus 70. So you see here 50 plus 20, 70, so 0 equals 0. So it satisfies. Because these D and N perpendicular to each other and the point satisfies the equation of the plane, it means the plane contains the line, or line lies on this plane. So this is a plane. Okay. You see, it is on the plane. Of course, we put the restriction on the boundary. That's why there is no part of the plane in the other case. But this is the case. Maybe I should write this. Okay. This is the case. It's on the plane, right? Okay. So this is the case.